This is pre-algebra lesson 6.8, percent of change. It's a pretty straightforward lesson. Here's the deal, here's the rule. If they ever ask you to find the percent of increase or percent of decrease of something, in other words, if you're going to take something, if I'm going to go from 5 to 7, okay, if I'm going to go from the number 5 to 7, they might say, well, what is the percent of increase? How much did you increase that? Well, if you were to, it increased by 2, right? But if they want to know what percent it increased, this is how you do it, all right? It's a very straightforward rule. Okay, here's the rule. To find the percent, you're going to want to write this down. To find the percent of change, here's how you do it. That is the amount of change over the original amount. Okay, to find the percent of change, it is the amount of change over the original amount. That's right, straight word for word out of your book. Here's how I write it. And you'll need to learn this. This is a term in math that you may not have known. A triangle. You know what a triangle means in math terms? Anybody know what a triangle means? It means change. It means change. So what you can do is you can just go, it's the triangle over original. That right there is the shorthand for this whole equation, this whole formula is the triangle over original. So then, here's the deal. If I'm going to go from 5 to 7, let's talk about this. It's triangle over original. How much did I start with? What was the original amount I started with? I started with 5, right? So then that means that the denominator is going to be 5. How much did it change? It changed 2. You would actually do a subtraction problem. It goes from 7 minus 5. It changed 2. So 2 over 5 in your calculator, you would put 2 divided by 5. Comes out to 0.4. Is that telling me the percent, 0.4? No. What do I do to turn a decimal to a percent?
Move the decimal point 2 places to the right.
To the right, 1, 2. So it would be a 40%. Here's the deal. You would say this is a 40% increase. Because we went from 5 to 7, you'd say it was a 40% increase. Does that make sense? Okay. The other type would be if you went from 20 to 17. Okay. And I said, what was the percent of change? How much did this change? What percent did this change? Nothing changes. What is the formula? What's the rule? Change over original, right? The amount of change over the original. You should just have that down, right? That's how you find the percent of change. Is the change over the original. Okay? So then you're going to go, how much is the original again? What do we start with?
20.
Start with 20. How much was the change? How much did it change?
3.
It changed 3, right? You actually go 20 minus 17. It changed 3. You don't care that it's positive or negative at all because you're just wondering how much did it change. Because in the end, our answer is going to be the something percent decrease, right? This thing decreased 3, agreed? Mm-hmm. So then you go 3 divided by 20. 3 divided by 20 comes out to 0.15. What does 0.15 mean as a percent? 15%. There was a 15% decrease. Does that make sense? This was a decrease, 15% decrease. When we went from 5 to 7, it was a 40% increase. Does that make sense? Okay, just so we can be in the same ballpark. When something goes up 100%, what's another word for that? If it has a 100% increase, what's another word for that? It doubled. See, and that seems weird. If it has a 100% increase, a 100% increase, that means it doubled. Does that make sense? If it was a 50% increase, it would be half as much again. So if I had like a 10, if I had a 10 and it increased 50%, It would be half again. What's half of 10? 5. So then it would be at 15. Does that make sense? And if I said, what is 50% of 10? That's 5, right? If I said it decreased by 50%, then you'd go, okay, well, it would be 5. A lot of these things, it's difficult for people to estimate only because if you'll just back off and think, okay, what is a 25%? Let's say they're talking about 27.6%. You go, okay, well, how can you estimate that? You could just kind of do a 25% of something and go, okay, what is it? What is 25% of this? Or, just use benchmarks, use numbers that make sense to you. Anyway, I'm going to give you a couple to see if you have this. Okay, we're going to go from, and you can use your calculator. You're going to go from 2.0 to 3.2. Do that one for me right now. Here we go. So here's the deal. What's the formula to finding the percent of change? Change over the original. And how do you write change? Triangle, right? Change over the original. And I just put orig, right? But that's the formula. Okay, so then how much was the original? 2. And how much did it change? 1.2. You can see that, what? Right?
Yeah, I wrote 1.5.
Oh, yeah, no. So then you would type in 1.2 divided by 2. What's that come out to? 0.6. What is 0.6 as a decimal or as a percent?
60%.
60.
Oh, I wrote it as a decimal.
Right. And then here's the deal. If you wrote the answer as 60%, I'd mark it wrong.
60% increase.
You'd say it's a 60% increase. You got to know, right? Because it went from 2 to 3.2. It's a 60% increase.
Can we abbreviate?
Sure. I don't care. I just want you to write down that you have the right answer. Yes?
Wait, so you divided 2 and 1.2?
Listen, here's the formula. Agreed? That's the formula. The change over the original. Did I put the change over the original here?
Yes.
So then how do you type that into a calculator? 1.2 divided by 2.
Okay.
Try another one. So one thing you'll notice is this. This is very important. You went from 4,000 to 8,500. What can you just ballpark here? It did something. It more than doubled, right? It more than doubled. So then we know that this thing is going to be over 100%. Does that make sense? It more than doubled. So you know that. That's kind of where you estimate. That's the quick little 2-second estimation that you're going to do in your head. Is you're going to look at that and go, wait a second. Oh, wow, it over doubled. If it tripled, what if it tripled exactly? What percent increase would that be if it tripled?
300?
How much?
200.
200% increase, right? 100% increase is doubling, then 200% would be tripling. Does that make sense? Okay. Anyway, so to do this again, it's change over the original. Whenever your teacher, like me, is okay, if they're allowing you to use a calculator and they still say, I want you to show your work, how can you show your work here? What can you do to show your work? What can you do?
Write the amount of...
So here's what this is really what you're going to do, because this is what, if I was a algebra 2 or a trigonometry student in high school and they let you use calculators all the time, you would still need to write down the problem set up properly. That's how you'd show your work, is that you'd go like this. You don't need to put that there word for word, but you would go, okay, I know what the formula is, and so I would go, 4,000 is the original, and 4,500. There it is. I've written that out. I've written out what I'm going to type in my calculator. Now I type it in the calculator, and it comes out to 1.125. Right? I would write that down. I'm showing my work here by writing that down, and then I would go, oh, I get it. I now need to turn that to a percent. What do I do? Move the decimal over. I would write that right here, and guess what? I'm done. I would now go to my answer column and write down 112.5%. Increase. I still showed my work. I used the calculator, but I showed my work. I showed how I got there. The teacher does not want to see a blank page. If they see a blank page, then they're like, well, maybe your mom did it. Maybe your friend did it. Maybe you just copied the answers down. But if you will write this down, you still get to use your calculator. You're just showing that you know how to set it up. Do you understand what I'm saying? So that's, whenever I do it, it's not often, but whenever I do let you use a calculator on an assignment, I still want to see this. I want to see that you know what you're doing and that you didn't just copy from your friend. Okay, try this one then. This is kind of an easy one. It goes from 9.6 to 4.8. If you were really good at mental math, you would be able to do this without doing anything. But some of you will need to. Okay, so for those of you who know quick, are quick in your head, you notice that 4.8 is exactly half of 9.6, right? So then you go half. Well, then how do I write that? What percent is 4.8? Then it's not. It's half, which is 50%. A 50% decrease, right? You got to put decrease there. If you don't put decrease, then you're a little confused, or you're not going to be explaining to the teacher or whoever's reading it exactly what's happening. Now, here's how you do it, though. Change over original. The change is 4.8 over 9.6. And that, when you divide that, it comes out to 0.5, which is a 50% decrease, right? Okay, try another one. Not so simple. I want you to round to the nearest tenth if you need to. Round to the nearest tenth. If the teacher's, well, you'll see what I'm talking about. We'll talk about it. 202 to 192. When you use a calculator, these big ugly problems are no problem, right? I mean, it's no different than using if it was a simple, straightforward, using a calculator. You just have to be able to round to the nearest tenth quickly in your head, by looking at the numbers, right? So here we go. 202 to 192. Change over the original. The original was 202. The change? 10. 10 divided by 202. What's it come out to? What does it say on the calculator exactly? What does 10 divided by 202 say? Point what? Say it again. Point what? 0. 4. Okay, so it's one of those, it repeats, right? Okay, whatever. Where's the 10th? Where's the 10th place? This is the 10th place. Right? What's the change, Jack? How much was the change? How much did it change? Jack, how much did it change? Oh. So there's the 10th place, right? That's the 10th place. What do I quickly do to tell what's going to happen with that? He looks over here, sees that it's a 4, right? Oh, sorry, it says round to the nearest tenth of a percent. Oh, okay, hold on. Let me go back here. Where is this? Here's the decimal. How do I write that as a percent? What do I do to turn a decimal to a percent? 1, 2. So it comes out to 4.950495%, right? They say round to the nearest tenth of a percent, which is right here. That 9 looks to the 5 and sees that the 5 is enough to make the 9 go up to make it a 10, which makes this 5.0. Would you put 5 as your answer? If they tell you to round to the nearest tenth, you have to put the tenths place. Does that make sense? If they tell you to round to the nearest tenth, you have to put the tenths. So that's the answer here, not that. Does that make sense? And it would be a decrease, right? A 5.0. It's not a 50%, obviously, since 192 isn't half of 202, right? Again, that's where it's that 2-second estimation. You go 50%. Oh, wait. Oh, no, that can't be it. Right? Okay. Try another one. Round to the nearest tenth of a percent for me. 854.5 to 60.6. Shouldn't matter. You're using a calculator. Okay, here we go. What's the formula? What's the rule? Change over the original. You guys should all know that. Change over the original. The original amount is 854.5. Now, how do I find the change? I would use, since your calculator's right there, I would do that too, but you don't have to if you wanted to write it out. How do I find the change?
854.5 minus 60.
You subtract, right? Isn't that how you find the change, is you subtract? So what is 854.5 minus 60.6? 793.9, right? And now what do you do with this? You just type in the calculator. What is 793.9 divided by 854.5? What's it come out to?
0.929.
Okay. 0.929, what?
0.
Okay, 0.9290. Now here's the deal. 813. I need to turn this in. That's the decimal. What is that as a percent? What do I do? Move it to the right. So it ends up being 92.90813%. They want you to round to the nearest tenth of a percent. How do I do that? You look at the tenths. Where does the tenths look? To the right, to the 0, and go, oh, okay, the 9 stays the same, so it would be a 92.9% decrease. Make sense? You guys all got it? I think you should all have it now. Let me give you your homework. Today is Wednesday? Tuesday. I was getting ahead of myself. Page 326, 1 through 38 even. Why so many? Because you're letting you use a calculator. Now, do you need to show your work on each one? Yes. How do you show your work? Just writing, listen, whenever a teacher says show your work, when you're using a calculator, it means writing out what you're typing into the calculator. And then writing down the answers, and then, that's it. You still get to do the hard part on the calculator. You have to show your work on your paper.